Okay, so here we got RS Logic 500 running, right? So we've established communication with the PLC. Okay, that's the first thing on a new PLC. Number one is to do what? Establish communication with it. For Allen Bradley products, we use a program called RS Links. It actually installs when you install the application. So it's automatically, it's got that suite that it puts in there. The problem is when I go online, it still can't find you. All right.
So it's not picking up the driver.
Well, yes and no, but this is where what we have to do. We have to see right here where it says comms, and what I'm going to do is I'm going to come down here and say system comms, and now I'm going to select. This is what we can do is RS Logic can control. We can program a bunch of PLCs on the network. So what we have to do is tell RS. We have to tell RS Logic 500 which PLC on the network we're working with. So I'm going to come down here and select my PLC, and then I should be able to go online now. See, so we're okay. So I just can't, there's another step in there, right? So we establish communication with the PLC using RS Links. And then when we all open up RS Logic, we use system comms to tell it which PLC on the network we want to actually connect to. And of course, what it's going to do is it's automatically going to download whatever programs in the PLC for us. If I go online, I can still say cancel, right? And so it actually uploaded whatever's in the PLC.
That's program is on that PLC right now.
In the PLC. This is it. A little different than Siemens. When you upload a program from your PLC, it don't give you symbols. Those symbols are stored in your application. On your Siemens PLCs, the tags are stored in the PLC. So if you upload a program from a PLC out of a Siemens, you get your tags too, which is a lot better. So on the left, what do we call this? Yeah, this is the project tree, right? It shows us all our data files here, which the book has a tendency to call registers, but they're not, they're data files. And then this is our processor status. We'll look at it. We're going to use this time. This is a free running clock. Well, it's not a free running clock. It's a clock. It's running at a certain speed, which we'll have the ability to use to do things. Instead of using those cross-coupled timers, this is available. We'll show you how to access that. Here's where our error codes are here. So these are different error codes. So it's going to give you a number, and then you'll have to look up the code, right? So it's so here's the actual fault number right here. So anything else? This gives us our scan time, which is constantly changing. This is the status register for our math operation. We're going to do math. We're going to let y'all work with math this semester. Are we okay? So right now, this is a hybrid PLC. So what we would do, I think we talked about that, which means we would come up here and attach things to this side on the left, right? I mean on the right, I'm sorry. Slow down, Rick. So this thing has an access thing on the side over here, which is where we would take this off and then we could buy modules to plug into it. So it actually, the backplane actually comes through the PLC itself. Fine. Are we okay? And so if we did have modules on this is designed to mount on a DIN rail. This is called a DIN rail. This is standard. You'll run into these all over the place. And so we can take this off. It snaps on there. And we could just put other modules over here. We could put multiple modules. It's just that they would do what? They would just daisy chain or plug into each other. Well, if we did those modules, then of course now what we're going to have to do is we're going to have to configure the I/O, right? So right here I go to I/O, and then these are all the modules that's available for this PLC, for the 1100, for this 1100, right? So these are all of them that we could buy. So there's that 32 bit input port right there. And it's a sourcing port, right? I'm sorry, sink or source. So that means we can tell it what we want it to be. Here's the 32 bit output port. Output module that we could plug on there. And if we use that, then we'd have to specify a slot number, right? You understand? And we'd have to specify what? A word. Well, that's all of them that's available for this PLC. So it's got a pretty good, are we okay? Make sense? So a true fixed PLC, you don't configure the output because it's all built in. These hybrid PLCs, they're going to come with what? A certain number of inputs and a certain number of outputs, and then you have the ability to put modules on it so you can add more inputs, add more outputs, add more analog stuff, and that kind of stuff. Are we okay? So if we didn't want to use this one, then we would do what? Then we would go up here. Sorry, we could go right here and say what? New. And we're not going to save this because we got a copy of it somewhere. And then now this is creating a new program. So when y'all say select the CPU, that's only if you're what? Creating a new program. Because it's got to load in the right compiler. It's got to load in the compiler for this PLC. This PLC speaks machine language. I'm programming in a high-level language, so we got to have a compiler is that program that takes a high-level language program and converts it into the binary language for the PLC. So that's basically one of the things that we're doing here, plus establishing inputs and outputs. So luckily, this don't have these big old model numbers out here. We can look at the model number. It's on the label on the side. Unfortunately, as soon as you put a module on there, you cover up that label, right? You understand? So that would be one thing that you might want to do. Luckily, there's not many versions of this PLC, which I went right past. These are Micrologics. They're 1100s, and if you look at the label over there, it's a B. So now we're ready to roll, right? So what do we have across the top? That's your quick access menu across the top. It just gives us the ability to create a new rung, right? So this creates a new rung. This creates a down drop or another line, right? You understand that. This is for our examine if closed instruction. This is our examine if open instruction. This is our output energize instruction. This is our latching output latch, and this is output unlatch. Are we okay? And then I don't know what these. Oh, these are for sending ASCII codes between. And we won't use those. Are we okay? Are we okay? If they're not in the quick access list, then we're going to scroll through these tabs, and these are where the instructions are set up. So here's the bid instructions, and there's the ones that we've got, right? You understand? So we don't deal with one shots on in here. In this class, Tech PLC 3, we'll play around with one shots and all the other neat stuff. But this is where we're going to start off right here. We're going to start off with what? Timers and counters, right? Okay. So what's the two types of timers that we have?
Timer on delay.
Yeah, on delay and off delay, right? Okay. And then of course we highlight a rung, then we come back go to our bid instructions. By the way, here's another thing. But what you have to do is you have to understand these mnemonics that it assigns to your instruction. Right here, this is your entire instruction palette. You'll see that? So instead of me trying to go through all those menus, I can come up here and use my instruction palette and pull that up there. And I can leave that up on the screen, right? You'll see that. Here's a examine if closed. Here's a output energize, right? See that? But you have to know the mnemonics, which would be this right here. So if I wanted to go my timer, it's pretty straightforward. Timer on, timer off. So instead of me going through all these tabs, every instruction is right here for me. That anything that's grayed out is not available to this PLC. It's an instruction that's part of, and it might be in another Allen-Bradley PLC, but it's not supported by the 1100. Does that make sense? So here's the timer. By the way, the error comes up automatically, right? You understand that. As soon as you insert a new rung, then it's going to come up and make that rung an error because there's no inputs and there are no outputs, right? And how do you make it check? How do you check if it's going to compile okay? You come up here and do what?
Verify.
Yeah, you can verify it. And if the E's go off, it's okay. If the E's don't go off, it means you still got a problem, which means you got to have a problem. Down here, what it does is show you what's wrong there. It says there's no operands entered. There's no information entered about these guys. So what do I need? Yeah, here we assigned this an input, maybe 0/0. Here I'll assign this to an output or an internal coil, 0/0. Now what you're supposed to be doing now is you're supposed to be assigning a what? Not a comment, a what? A symbol. Everybody understand that? You can't address by comments, you can address by symbols. If I needed to explain what that thing did, then I would give it a what? I would give it a comment. But your symbols are going to be little short names so I can pick that thing up real fast, right? Understand? If you go away from it with your mouse, it's not going to give you the option of assigning a symbol. But if you forget, what can y'all do? You can right click, right? And then go to what? Edit symbol, right? You understand that? Or you can go where? Yeah, you can go to your symbol table, which is down here somewhere. Oh, I got to get rid of these. I can't see. Yeah, so here's your symbols right here. Address and symbols. Oh, I'm sorry, that's the picker. Yeah, here's your address and symbols. So if you assign a symbol, if you try to assign a symbol to something and it don't let you, what does that mean? It's already been taken, right? You understand that? So what would you have to do? And we have this happen all the time, especially in intro to PLCs, because people will use address reports that's not even there. And then when they try to reuse that symbol, then it won't let them do it. So what can we do here? We can assign them a symbol here. So we could go ahead and assign all the symbols to our ports, or we could do what? We could delete a symbol, and then or come over here and do what? Just reassign it over here on the left, right? That makes sense. So, very similar to Siemens. Siemens has a tag table. You go in and do the same thing. So very, very simple. So here's our timers. So down here, they're in alphabetical order. So here's on delay. I can just grab it and oops. I thought I could. Oh, I gotta identify. I can come up here and drag it in there, right? Oops. I'm supposed to. We can put it, normally on this one, you have to put it where it turns green, right? Y'all see that? And it'll put it in there, but it automatically put it on the right because it's considered to be an output instruction, right? So y'all okay on the instruction tablet? Pretty neat, right? This right here. That thing right there that shows nothing, that brings up your entire instruction tablet. You could hide it like over here on top of your project tree. You still have to identify the rung you want to put it in, right? And then you can just slide it over.
You got to put a rung down before you put it up.
You got to put a rung down before you do anything. And you got to highlight the rung that you want to put it into. So that makes sense. Are you okay?
Sometimes you do the automatic address for it. Then try to go back and put the symbol in. It won't pull up an option.
Yeah.
So I like that.
Going into the symbol table, yeah. Yeah, when we start typing in the addresses, it'll start, if there's any addresses available down there, it should, on this one, I think it does it on timer. It shows us the next available, should show us the next available timer, right? Y'all see what I'm talking about? So I could stop right now and do what? Yeah, just click it on that. So what it's going to do automatically, as soon as you start typing, it's going to show you the next available option that's there.
Also, enter twice.
Okay. Now duplicate. Are we okay? So what's this? First of all, we have to assign it a logical address, right? Here, right now, what they do is they dedicate T4 for timers, right? That T for timers, 4 would be data file 4. But the 1100, you can use anything above 9. Let's see if that works. So I can say T9 colon 0. I'm sorry, 9, Rich. And it takes it. So what we can do on the 11,000, on this, is we can use any data file. By default, it's going to do what? T4, data file 4. But we have 9 up to 255 available on the 1100. All right, so that's a lot of timers, a lot of counters. But now you're going to have to manage your data files, right? But what it should have done, it should have put no, it didn't. So I'm going to have to manage this data file. I'm going to have to, if I've used 9 for timers, I can't use it for what? Counters, right? You understand that? So I have to manage these now. These down here are managed by the application. Okay? Project T9. What else do we need, guys, for timers? We need a time base. This is a time base supported by this PLC. So it has a multiplier. A time base is the multiplier, right? You understand? This PLC supports ones, which is what we use most of the time because most of our labs tell us in seconds. But if I do like 1.5 seconds, then I can't use 1. I have to use what? I would have to use the multiplier of this guy right here. Right? You understand? We don't have a 0.1 on this one. We got a 0.0. Right? So if I wanted 1.5 seconds, I'd use 0.01. And then my what? My preset, I would use 150. Everybody understand? But now I can do milliseconds, right? And then my preset, I would put 150. And then that would give me what? 1.5 seconds. Everybody okay? That makes sense. And then the accumulator comes set to 0, guys, but you can set it anywhere you want to. By default, it's at what? 0. So you can start the timer timing from something besides 0. And we can address these registers too. We can address the preset register. It's a word. And we can address the accumulator, which means I can load this thing from anywhere. This is what we call constants. Constants, so we have variables and we have constants. What's the difference between a variable and what's the difference between a constant?
Variable. Okay, bro. A variable varies.
You can vary it without changing the program. I can come up here and change this, but literally if I've changed that to 200, I've changed the program, right? So in PLCs, a constant is an operand that you have to change the program. A variable means we can change it without doing what? Without changing the program. We can do it on the fly. And operands, what are operands, by the way? Look, uses this a lot. This came up from microprocessors when we used to do machine language programming. They say we have codes. We have a code. We call them operational codes. These are the binary codes that tell the processor what we want to do. And then we have the information that we're operating on, and those are what we call operands. This is moved into PLCs. So the operands are the numbers that the PLC are operating on, right? You understand that? So let's call it an operand. And that's in the book several times, but they don't define what an operand is. So we'll check for errors. Is this going to be clear? Sure. The timers don't need. So output instructions are required. Input instructions is when you need them. So notice this might not work because this guy's going to come up in time as soon as I load this program in here, right? You understand that? And I have no way to reset it. But it's not considered a syntax error. It's in the right syntax. So inputs are not required. Y'all understand that? And we do have some instructions later on that we don't use. So if I wanted this to work, what would I do, guys? I'd come up here and maybe put an input down here. And then I'd sign it what? So I'm going to say input colon 0. And then we'll put /1. And this is where I assign it a what? Symbol, right? For errors, everything's okay. Now it doesn't mean it's right. It just means there's no syntax error, right? Syntax errors is the correct way of writing in a language. So I might upload this, and I wanted to use switch 5, and I used switch 1, right? You understand? It's going to check. It's going to be in the right syntax. It's not going to give you an error. It'll upload correctly, but once you get it uploaded, it's not going to do what? It's not going to work the way you want it to. Or downloaded, excuse me. Got to get that internet stuff out of it. Download it into the PLC. This is where you do what? This is where you name it right here. So this is where you name your program. On Siemens, as soon as you say create a new program, it's going to ask you to put a name out there. So they call them projects. So if you don't give it a name, it's going to give it a project number. Here, if you don't give it a name, it's going to leave it as what? Untitled. And then we can say this. Processor. You can name your processor. So right now your processor is named nothing. You can give your processor a name. What did it say? Okay. And we're going to switch to the run mode. I was trying to see. I know Siemens actually puts the processor name out to the side. I don't see where this actually shows that. So are we okay? So we're not using something, but as soon as we energize the switch, it shows us the flow, right? So this is a very, very good troubleshooting aid. And then when we energize the timer, it should do what? You know. And then, so we're using the enable and the reset is the same thing. So this guy right here automatically resets the accumulator to what? When you disable the timer. Disable it. Are we okay?
You're saying when you flip it back off, it resets automatically.
Yeah, so if you loaded it with a number, you'd have to reload it. So if I came over here and put 15 in here, right? So if I came over here and put 15 in there and then downloaded this, then of course it should start 15, but when I disable, actually reset it to 0, we would have to, in fact, that started with 0. So I have to load it from 0, but we can. So let's go offline. And then what I'm going to do is I'm going to insert a run here. And we'll just put it right here. And I'm going to come up here and put another switch down here. And then I'm going to come up here and put a move instruction. Oops. I didn't have the wrong highlighted. And these two are going to be made, but we'll go ahead and use them. So my source is going to be input 0.0. And then my destination, let's put timer 9:0 dot. We'll put it in the preset register. PRE, right? I think it'll give us the error if it's not. Check syntax. Got a problem? Oh, it's got right here. It's going to load this in too, so this is a fairly good example, but everything looks okay syntax wise, right? So notice what happens when I start popping these switches over here on my panel. What do you notice on my source? That. So what we're doing now is, this is where it comes into play. So I'm taking the content of my input word 0, and I'm putting it where the preset. So this would be definitely what we call a variable, because I have the ability to do what? Change it, yeah.
So it's,
I'm listening.
we lost 25.
Yeah, but it's binary, so we'd have to, so here I come over here, this would be a 1, right? This would be a 2, this would be a 3, so I've got switch 1 and 2 closed. Then that would be a 7, so it's binary. You'd have to look at the switches and convert that over to decimal to see what actually gets loaded in there, right? Understand? So this is F, so that would be a 15, right? So I have switches 0, 1, 2, and 3 closed. So this would be the biggest number I can load into this. That's all 9 of my inputs, which would be 1023, which is one less than 1024, because I got 10 switches. 2 to the 10th. 10 switches, 2 to the 10th is 1024, minus 1 because 0, right, to understand. So the biggest thing I could load in here would be 1023. And my timer is not going to do anything because I have to enable both of them at the same time. So I loaded it once, now it's going to time up to whatever multiplier that would be. So this would be, I could actually input from switches. So you'll see they call them thumb wheel switches, where you come up here and you turn thumb wheels. You know, it'll actually give you the binary code for you to go into your PLC for you. So in fact, the Logic Pro software's got that available to it. Some simulated thumb wheel switches. So I can simulate thumb wheel switches on an HMI panel, where I come and push buttons, and I can raise the number or lower the number, and then I could load that into my timers, or I could load it into my counters. I could load it any way I want to. These move instructions are very popular, but these move instructions, this is the source. So what could the source be? Well, the source could be the results of a math operation. The results could be the source of a logic operation. It could be the source of an input port, right? Understand that? I can bring that in. And then I can move it into a preset register. I can move it into the accumulator. I can move it into my counter, right? You understand? The preset on my counter. And in that way, we actually get a true variable where I can do it on the fly, right? You understand that? The one they use in the book is they have two different numbers in a move instruction where we load a constant, but it turns into be a variable because I hit one move instruction, it loads it with one number. I hit the other one, it loads it into another. But this right here, this guy here can definitely be dynamic, right? You understand that? We can load, that move instruction is very, very powerful. Because I have a what? I have a source. What's the source? This is where the operands are coming from. And then I have a destination address. This is where I'm putting the operand. So any register or any data file that's addressable by George, I can stick stuff in it with a what? With a move instruction. Real powerful. So what's our other type of timers? So we have an on delay timer, we have an off delay timer, and what's an off delay timer? So this guy here starts timing when the rung is what? True. A off delay timer would start timing when the rung goes what? False. Everybody okay? And then we have a retentive on delay time. What's the retentive on delay time?
Back. That's what you do for the flashing light, right?
Not for retentive. Wait, that's what we call cross couple time. The retentive.
Yeah, keeps the accumulator even after it's reset.
Yeah. So if we come up here and we put a retentive timer in here, and we've only got a retentive on delay, right? Everybody okay on off delay? I need to put one up here. Everybody okay? Yes? No? Jobert's okay. So we'll come up here. So we'll come up here, bring up our palette. We'll come in and we'll put another rung in here. And then I'm going to take this off. Let's get rid of this rung right here. So y'all see how the move works, right?
So we're using the move instruction in this class, Mr.
Yeah. Well, we started using move instructions in timers. We showed y'all never did a lab where you had to do it, but they were talking about loading the timer with different things. Now, what they did then is they had two move instructions that were set up with constants, but it made them look like variables because we would press a different button and it would load the timer with different things. So what we had is so we had one move instruction where the source was like 1,000, and then we moved it into, I don't remember if it was the counter or the timer, but we moved it into like T4 0.0, and you push the button right here. So this would be like input 0/0, and then we had one down below that, which was input 0/1, and then we had another move instruction that had maybe 2,000 in the source, and then we took, I'm sorry, this would be ACC, and then we went to T4 :0.ACC. So if you press this button, it would load it with 1,000. If you press the other button, it would load it with what? 2,000. I don't remember what it was. So what's happening is this would be a variable because I could load it with different numbers by depending on which button I hit. But we notice that our move instruction, our source can be anything that's addressable, right? So if I could address an output register, and I could take the results of the output register and I could put it into the accumulator. Because that output is addressable, right? So I could come up here and I can say output : 0.0, and it would come up here and it would load the output register, not the outputs, the data file that holds the outputs, right? You understand that? Oops, wrong thing. So right here, this guy right here is addressable. So if I come here and double click on that right there, that's an address. So I could take the state of these outputs right here, right, ones and zeros, and I could load that into a counter. I could load it into a timer. I could load it into a math operation. Because any data file that's addressable, we can load that in just by specifying a source, right? Or a destination. I could use a move instruction to set this output to any way I wanted it to be. Right? You understand that? So I could come up here and say move FF or 65,536, and I could hit a button and all these guys would go to what? They would go to ones. And all the outputs would do what? They would go to ones. So I could come up with a pattern that I wanted this thing to go to, my outputs to go to, and I could do it with one move instruction. So let's redo this. Let's come up here and say, so what do we want to load it with? Let's just say like 255, which would be all else. And I'm going to come over here and I'm going to put it into output : 0.0. And so what's going to happen as soon as I press that button, all my outputs the last 8 outputs are going to go to 1. Oops, I don't like something. Undoubtedly, it's not going to let me do that. I might just lie to y'all. Run has no Oh, I'm sorry. Run 3. Thank you. Okay, so it's okay. So let's go ahead and download this. And then we'll bring up our output. Oh. This guy, right? And then I'm going to switch to. You see what happened to my output data? And all these lights came on. So I could literally control outputs without using coils. If I wanted this motor to turn on and this motor to turn on and this motor to turn on, with a timer, let's say a timer, when a timer timed out, I wanted to switch from this set of motors to that set of motors. We could do it with a watt instruction, move instruction. Ain't that neat? Y'all didn't see the lights come on, but all the lights on the front came on.
I saw the zeros turn into ones.
Yeah, you saw the zeros turn into ones and you saw the outputs respond. So that move instruction is an extremely powerful instruction. So I could set up a pattern of what I wanted to do, right? You understand? And just do what? Hit this button, I turn this output on, that output off, this output on, that output off. Hit another button and rearrange the whole thing just by hitting a what? A button, right? You understand that? And we're going to find out later on, we're going to talk that we have something that does that for us. It's called a sequencer. We could literally set up a sequence that we want it to go through, and we could advance through a table, but it's doing the same thing I'm doing it here, but it's doing it with what? With one instruction. Very, very powerful. Very, very powerful. So if you are looking back at the book, I don't remember what chapter it is, I don't talk about sequences, and that's the same thing as here. So any data file, so any one of these things right here, I can put information in them with a move instruction. Any one of them. All I got to do is just know what the address, right? Of course, it's got to be words. We can't use we can't move a move instruction. We cannot use bits. It's not a bit instruction. It's a word instruction. Y'all hear me? Yeah. So you got to move a whole word. So you have no option with this. So this takes that whole word. So even though I put 255, it actually would have cleared out all the other bits up there, right? So one instruction. So in the Siemens PLC, that's what they do. When you hit reset, it just stores a pattern out into those output ports, and automatically everything goes back to the reset position, right? Which is pretty neat. Very, very, very powerful instruction. It scared me for a second there. I'm glad y'all saw that. So, off delay, let's put an off delay timer there. We'll bring up our instruction palette. It's down here somewhere. So what's his mnemonic? By the way, I didn't tell y'all that. Y'all know what you can do, right? So you can stretch it out to make it, right? Or you can do what? Shrink it in and it automatically adjusts for y'all. So here's our timer off. This is this guy right here. Can't put it in, huh? POF, right? So what do I need to do? I need to put in another rung, right? By the way, I like this too in that, you can, once you highlight a rung, what you can do is you can just do what? You just keep clicking and it automatically does what? Insert them in there for you. So I like the palette, guys. Y'all can use this if you want to. It's up to you. Timer off. Of course, even though I try to put it over here, it automatically goes to the right because it's considered an output instruction, right? And then RTO, this is our retentive timer, right? And we're not going to play around with our move instruction. We'll use constant. So let's go ahead and delete this rung. So you can delete an whole rung just by highlighting the rung on the left-hand side, right? Hit delete and it'll delete the whole rung. But it's not going to be one of those oops. So it's not like Microsoft Word where you got that little arrow, right? When you delete something, you said, I wasn't supposed to delete that. You just hit the back arrow and get it back. Once you hit delete on that, it's what? And it's gone, yeah. So this is off delay. So we'll come up here. We'll just use the normally open, examine it. And then, what do we have to do on this guy? So our retentive timer, if we want to set it back to 0, what are we going to have to do? We're going to have to reset it with a reset instruction, right? And then we'll come up here and we'll put these control by switches. So here's our off delay. We'll assign it to the same one that we assigned above. So one of them's going to time when the switch is closed, and the other's going to time when it's open, right? This will assign it to another switch. I don't know why I'm keep hitting you. That needs 2, right? And then I reset. We'll use input. Okay. So what do we want to do with this guy? We'll use a 1 multiplier. We got to do what? Got to give it an address, right? Okay, we'll use 4 for this one. We're not using symbols. Y'all gonna have to use symbols. A multiplier, and then we got to give it a what? Preset. And our tentative timer, we'll give it a different address. Yeah, because we're using a multiplier of 1. They don't call it a multiplier, but it's a time base. They call it the time base, but that's what it is, a multiplier. So what you do to get the time is you take the number and you preset and you multiply it by this. Right? They don't call it a multiplier, they call it a time base. Siemens is a little different in that we specify seconds or milliseconds and stuff like that. You specify it in the instruction. You don't specify it as a multiplier.
It's like robot and robot should be different.
Huh? Go ahead.
Robots, like different seconds or milliseconds.
I guess so. Oh, you mean for your speed? It's usually in millimeters. Yeah. The ones I've seen is the only option that's available over there. I don't think it got more. Well, I don't think the ones we got got more. So we'll call this 1, right? Is that okay? And then it's going to automatically, if you hit enter, it's going to automatically take you to the next requirement. If I hit enter here, it'll drop me down to my preset, and we'll put 10 here also. But my reset, I have to do what? Yeah, I have to give it the address of whichever timer I want it to reset. So the reset instruction, we use it for counters and we use it for timers. Same instruction, right? Everybody okay? Check it for errors. Looks okay. Looks in the right syntax. We'll come up here and we'll download it. Oops, I need to turn off some switches. Okay, when we close switch 1, what we'll notice is the first timer starts timing and the bottom timer reset, right? So off delay timer resets the accumulator to 0 when the rung is true. An on delay timer resets the timer to 0 when the rung goes false. Everybody understand that? Okay. So the first one's timed out. We got a timer done. This one says it's done already, right? Yep. So this is switch 1. So let's close switch 1. Timer 1 resets to 0, and then timer 2, the off delay comes up and does what? Now here the done bit is opposite of what we expected to do. Right? So here the done bit, off delays, the done bits goes false when the timer times out. And how do we reset that one? We make the rung true. So as soon as I make the rung true, right? So to reset the on delay, we make the rung go false. Y'all understand that, right? Okay? To reset an off delay, we make the rung go true, right? Okay. The on delay, the done bit sets when the rung is through timing. An off delay, the done bit resets or goes false when it's through timing. That's what you'd have to do if you're going to do that. Now my retentive timer down here, it's an on delay. That's the only retentive timer we have available to it. It's running off switch 2. Oh, sorry. Let's turn the reset on. So switch 2, it's going to start timing. I can take it false. When I take it false, let's reset it. So we're doing switch 2. I can turn it off, and what does it do? Make stops. Turn it back on, continues on. Turn it off, it does what? Stops. Turn it back on. Turn it off, it stops, right? You understand that? On these other ones, they would reset instantly, right? When it times up to 10, what do we have to do? Somebody did this, by the way, in class, is they used the timer to reset itself. And they say, the timer keeps timing. Every time I reset it, it just starts back over because why? They left the rung true all the time. So it was pretty interesting. So what they was doing is they was using the done bit up here. So when the timer got done, right, you understand, it reset itself, and then it automatically started doing what? Timing again. So I don't forgot who did that.
So the done bit on the emphasizer?
Yeah. So they had a done contact over here on this side right here. They might have been the on delay timer. So that's what it was. It was the on delay timer. They used the done bit. So every time it got done, it did what? It automatically reset itself and did what?
They had start contacting the timer, then the done contact.
Yeah, so what they did is they came over here on their own delay timer, this right here, and then they had a contact. Let me identify. I am offline, thank you. So what they did is they came over here and did this, I'm sorry. I gotta change it over to, this is 9/0/done. And then, wrong thing. They use an examine if open. No, they use it. They didn't change, did it? Oh, I know what I did. So they did this. Of course, when I make it true, I couldn't figure out what it was doing. Yeah, because as soon as it's done, and they said you never see it because it's so fast, right? So as soon as it got through, the done would open. It would reset the timer, which would cause the done to go back on the close. And they were saying, I can't this timer just keeps running. This timer keeps running. I don't think if there's one of y'all, I'm sorry, I'm making fun of you. See what it's doing? So that's their 3 types of timers. Are we okay? So any questions, guys? So we're going to split out a little early. So what we'll do when we come back in the class Wednesday is we'll look at calendars and we'll look at labs.